Everyone knows Australia, where it is, what it looks like, what strange and dangerous critters live there, and the fact that almost everything that resides on the continent can kill you. Even the soil has been known to cause a few casualties. But it's also old. It is so old that if you had a DeLorean and drove it across the geological timescale, traveling at a speed of 1 million years per minute, it would take you over 3 days to travel to the past when Australia was just an infant continent. So, to do a presentation on this incredible place, you have to be choosy, for there isn't enough time to go over everything that happened here. I have chosen 3 interesting features: the Aramanga Sea, with its Great Artesian Basin, the Bungle Bungle Range, and the Great Dividing Range, with their blue mountains. To begin, let's rewind a few million years back to the Cretaceous period. Here is Australia being bifurcated by a large inland sea. This is called the Aramanga Sea. Its creation was approximately 146 million years ago. Its range was over 1 million square miles and covered where modern-day Queensland, the Northern Territory, South Australia, and New South Wales reside today. It formed as the sea levels rose over 600 feet, and with Australia being at a low altitude, the rising level of water flooded into the mainland. The Aramanga Sea was shallow and full of life, but these were not considered dinosaurs. Instead, they were marine reptile creatures. One amazing feature of the Aramanga is that when one of these creatures died, it would sink to the bottom of the sea. And if it was lucky, what was once rotting just might become a thing of beauty. Opals are Australia's gemstone, and there is a reason for this, as 97% of all opals worldwide are mined in Australia. An opal is made of a hydrated form of silica and are mined in caves underground. How an opal is formed is in cavities within rocks. When silicate-laden water is leached through rock, it pools and the water begins to evaporate, leaving behind a silica deposit. This process is repeated again and again, and eventually an opal forms. However, occasionally, when the water meets a fossil, a biological treasure evolves into a mineral one as well. Ancient body parts have been known to become opalized. This happens when a cavity is formed by bone or shell, and the process of evaporation begins. There are 2 kinds of opalized fossils. One is when the internal details are not preserved, and this means that the silica solutions fills a trace fossil and creates a replica of that object. Another is when the internal details are preserved, meaning that the critter has not rotten away, but a left body fossil. Then the silica solution may seep into the crevices and harden around the critter. Another interesting feature that sprang up from the Aramanga Sea is the Great Artesian Basin. The Great Artesian Basin is one of the largest underground reservoirs in the world, and it provides the only reliable fresh water to Australia. It extends 2,400 kilometers from north to south, and 1,800 kilometers at its widest point. It spreads out over 1.7 million square kilometers and spans approximately 1/5 of the continent, and it contains 65 million megaliters, which is enough to fill Sydney Harbor over 130,000 times. The water it contains has been dated back over 2 million years ago. The foundation of the basin was formed when the major flooding that created the Aramanga Sea receded, leaving behind siltstones and mudstones. As these sediments hardened, they created an impermeable layer which would have spelled doom for Australia. However, the land wasn't completely dry, as there were rivers that existed during the time, and it is these rivers and these sediments that they carried that proved to be essential. The sandstone that was deposited by the rivers is instrumental in creating the Great Basin. When sandstone is layered over silt, this creates an aquifer. The water is able to pass through the sand and get trapped just above the layer of silt. The aquifers that trap the water between the layers restricts the movement of the water and forcing it either to the sides or up. The water is replenished by the rains that fall on the recharge areas, which happen to coincide with the Great Dividing Range. The Great Dividing Range is located off the northeastern tip of Queensland. This mountain range was created in the Carboniferous period, some 300 million years ago. It was formed when Australia collided with South America and New Zealand, and it stretches more than 3,500 kilometers as it runs along the entire eastern coastline. It is the most substantial mountain range in Australia, and it is actually the fourth longest on land in the world, and since then has been the victim of erosion. The mountain range separates the narrow, fertile eastern coastal plains with the rest of the continent. It contains plateaus, upland areas, and escarpments, and it consists of limestone, sandstones. Another interesting feature on Australia's landscape is the Bungle Bungle Range. These incredible mounds reside in the Purnululu National Park. When you see these beehive-shaped domes that are strangely striped orange and black, it makes you wonder how they formed in such a unique way. The tall domes were formed during the Devonian period and estimated to be about 350 million years old, and the uniqueness of them comes from the stacked ancient seabeds in the dolerite layers. The dolerite layers are from the accumulation of the biological waste from the critters living in the sea. And they are formed of sandstone and conglomerates and created in the Ord Basin, while active faulting was still shaping the land. The wind and rain have helped shape the mountains into their distinctive dome shape today, and the dark gray banding is caused by the sandstone with copious amounts of clay embedded in it. It also has a protective layer of cyanobacteria, which is a blue-green algae that can withstand heat in certain areas. The orange banding is caused by sandstone. This layer doesn't have much clay associated at all, and instead of cyanobacteria, it has a protective layer of iron oxide. This layer is only a few millimeters thick. These two outer layers protect the vulnerable soft clay-based sandstone underneath, and this also helps to slow down erosion and weathering.